So I thought I'd start off with a story today. About a month ago, in this very building, we hosted a colloquium on the future of petroleum engineering education and whether petroleum engineering would even be a viable option or a viable discipline for the coming future, especially in the realm of the energy transition and how much is discussed about it. And there was 55 worldwide faculty that attended this, along with several energy representatives from different companies. Now, let's face it, it's tough to get 2 faculty to agree to anything, let alone 55. But at the end of this, it was pretty evident that the resounding answer was yes, that petroleum engineering is not only a viable discipline for the foreseeable future, but it can also be part of the energy transition. So as John mentioned, I'm Jennifer Miskimins, and I'm the head of the Petroleum Engineering Department here at Colorado School of Mines. Now, given the audience, this might have seemed a little bit like a self-fulfilling prophecy, right? But bear with me here in a minute. So, as John mentioned earlier, and several people have today, oil and natural gas will be part of the energy mix for quite some time. However, there's no doubt that we need to do it in a more sustainable fashion, more cognizant fashion than perhaps we've ever done in the past. And we're starting to do that, and we have been doing that quite some time in our education practices. There's a lot of challenges with that, but with challenges there also come opportunities. And I think a lot of our faculty are working on those particular opportunities now. But what I really wanted to address today was actually to talk to you a little bit about some of the areas that might not be traditional in our particular discipline, that are fitting in nicely with other energy transition areas and give us opportunities to expand much of what we're doing and what we've known about for decades. And I wanted to speak with you specifically about methane emissions, carbon capture and sequestration combined with enhanced oil recovery, which is a mouthful, but we'll get there, and some geothermal energy. So you heard a little bit earlier about the discussions with methane emissions, and we know that during oil and natural gas operations, we do have methane emissions that do occur, whether it's through flaring or through other production operations. What we have is we have faculty in our department and other places around campus that are working on combining this flaring behavior to data analytics. And through this combination, we're starting to understand a lot more about how does methane emissions happen. And if you understand more about it, how it happens, you can understand a lot more about how we mitigate it. For instance, does one well emit constantly over a certain amount of time? Do we have super emissions? Does the measuring device itself have implications? And combining this with this data analytics and the millions, if not billions, of data points that are coming in are giving a lot of insight into this, which if you understand it, you can help to mitigate it and design better production equipment and better production practices over time. So that takes us to the second topic, carbon capture, sequestration, and enhanced oil recovery. What a lot of people don't understand about oil and natural gas reservoirs is we don't produce 100% of what's there. In fact, we only recover a certain percentage. It can be anywhere from a couple percent all the way up to around 50-55%. And we have a lot of faculty here that have been developing techniques anywhere from microscopic flow of molecules through rocks all the way up to building full-fledged computer simulations of reservoirs to try and improve this production recovery. Because think about it, if you can improve what's already there and improve that recovery, you don't have to expand your environmental footprint anymore. Well, couple this together with the idea of sequestration. Take CO2 out of the air, put it into the ground. It's out of our atmosphere, but by putting it into the ground, that actually leads to a technique called enhanced oil recovery. We inject CO2, we produce more oil and natural gas out the other side, out the other wells, to increase that production. And again, what this really helps us with is it helps us with not expanding that environmental footprint. The third area is geothermal energy. And this one's a lot of fun because when you think about petroleum engineering, it boils down to this concept of fluid flow in porous media, which is just a fancy way of saying we look at how fluids flow through rocks. Well, geothermal energy is exactly that also. Geothermal energy is just a different type of fluid. And to date, most of the geothermal energy that has been successful around the world has been due to certain combinations of geology, heat, and some other factors. Well, we here at Mines, and along with some other groups, are working on what's called enhanced geothermal systems, or EGS. And this is specifically taking the concept of petroleum engineering that we've done for a very long time and applying it into some different areas. Enhanced geothermal systems takes drilling 2 wells, we hydraulically fracture between them, and we inject water down one, cold water, through that hydraulic fracture to the producing well, and we inject hot water, heated water, up the other one for energy generation. And we are working with a large project, many companies and a lot of other universities are also, in Utah called Utah Forge. Utah Forge is a DOE project where they're looking at trying to improve this enhanced geothermal system idea. Specifically here at Mines, we're working on downhole tools that can withstand the heat that's going to be associated, but correctly direct those cold fluids through our hydraulic fractures in the most efficient way to gain that heat energy. So if I circle back around to the start of my talk and we start thinking about this idea of petroleum engineering as a discipline, I would argue that there is a lot of areas that not only do we need to improve the areas that we're working in historically in oil and natural gas operations, but there's much of the subsurface work that we can extrapolate to other areas such as sequestration and geothermal energy and improved operations overall. Proud of what we do here, and I think that not only can we be part of the solution, we will be part of the solution in the long run. So thank you very much. I appreciate your time today.